As with the previous chapters, I have included a debugging program for you to consider. This program is called Demo 13. You should retrieve it from the CD, and you may want to print this program as it is getting rather lengthy. You should first study this program by playing computer. That is, look at the program's code and step by step through the logic of the program to see if you see any errors. And also look for syntax errors. I'll first compile the program, and you'll notice that I received a message of 8 errors. And you'll note that the 8 errors are shown to you here. The messages indicate that a variable called number is not declared, that outFile is not declared, set precision and set iOS flags are undeclared, and so forth. If you double click on the first item, you'll note that there is a problem, apparently, with this statement. Study this program for a while before I discuss the solutions to this debugging program. The problem with this statement is that number is not declared in the program. As you can see immediately above this statement, number input, and the declaration of it being here, is what this variable should be. So I'll fix this, and if I look immediately below this, you'll note that the same mistake was made twice. I'll recompile this program to see what corrections have been made to this point. And as you can see, I only really knocked down 1 error. I'm now receiving a message of 7 errors. I always suggest to work from top down when trying to debug and correct programs. Our top message now says outFile undeclared. So I'll double click to that, and I'll notice that it sends me to the message that will open the output file called demo11.dat. Now the solution to this is the proverbial needle in a haystack. You need to look closely at the spelling of outFile and compare it to the spelling of outFile in the OF stream declaration statement immediately above it. And as you'll note, that C is indeed case sensitive. That needs to be a capital F to correspond to this capital F. Of course, both of these are made up names, and either spelling would have been correct. It's just that you need to be consistent. Let's now recompile the program, and we're now down to 2 errors. Set precision and set iOS flags are set to be undeclared. Well, these are not variables, so they really are not declared in that sense of the term. But you may recall from the earlier lesson that in order to use the set precision and set iOS flags, that there needs to be the IO manipulator header file declared as a compiler directive. And if we scroll to the top of the screen, we'll note that this header file has been omitted. So I will need to include that in the compiler directive section of the program. And so now we should have access to those manipulator stream operators. Let's recompile once again to see where we stand. And we now have 0 errors and 0 warnings, and we'll execute the program to verify the output. It appears to be working at this point. You should also check your program to make sure that it is indeed sending output to the output file, as that is one of the objectives of this program. The programs we've demonstrated thus far have used the sequence programming structure only, where each of the program instructions were processed one after another, in the order in which they appeared in the program. In many programs, however, the next instruction to be processed will depend on the result of a decision or a comparison that the program must make. For example, a payroll program might need to determine if an employee worked overtime. Assuming a 40-hour work week, the program can make that determination by comparing the number of hours the employee worked to the number 40. Based on the result of that comparison, the program will then select either an instruction that computes regular pay or an instruction that computes overtime pay. Before looking at examples of if or if-else structures, let's discuss the syntax that's required in the language C. There are 2 basic structures I will discuss. In both cases, the condition that you express must be placed in parentheses immediately following the if statement. If you want to execute one statement and one statement only, if that condition is true, then place that statement immediately after the condition, followed by a semicolon. The else statement, or the else portion of the statement, allows you to execute code if the condition being tested for is false. Once again, if you want one statement executed, you can place that statement immediately after the word else, ending in a semicolon. An alternative to this structure is to use a block of statements for each condition. That is, the condition is still being tested for is still in parentheses, and it still follows the if statement. If, however, you would like to execute more than one statement, if that condition is true, then use the opening and closing brace to specify a block of statements for that true condition. Likewise, for the else condition, if you wish to execute more than one statement, use the opening and closing brace for the else portion of the statement. Inside of the braces, you write code as normal. That is, you use semicolons to end lines of code just like you would if you were not using the if-else structure. Note also in the illustrations that the if and the else portions are indented. This is not a requirement of the C language, but it does make your code much easier to read and understand. Also, when using the block method, you should indent the opening and closing brace. Once again, this is not a requirement of C, but it does make your programs much easier to understand and to work with. Also, one tip, although it is not required in the if statement, it is a good programming practice to mark the end of the if statement with a comment, such as end if. This will make your program simply easy to work with and have a notation of the end of each if and if-else structure. The condition that is being tested must be in a Boolean expression, which means that it must be answered as either a true or false value. The Boolean expression can contain variables, constants, functions, mathematical operators, relational operators, and logical operators. We've already discussed variables, constants, and functions, and so forth. You will learn about the relational operators and the logical operators in the next segment. When constructing if and if-else statements, care must be taken to construct if statements or conditions that can be tested for true or false conditions. One way of doing this is to use the relational operators available in the C language. The operators are this symbol, which is the less than symbol. This is greater than. This tests for less than or equal to condition. And this will test for the greater than or equal to condition. These are pretty straightforward and are standard in most languages. The next two, however, are rather unique to the language C. The double equal sign is a symbol which tests for equality. That is, when you want to test to see if something is equal to something else, then use the double equal sign. Note that the equal sign, the lone equal sign, assigns a value, where the double equal sign will test for equality. There is a big difference between these two items, and we will look at examples of each of these. And finally, the exclamation point followed by the equal sign will test for the not equal to condition. So if you want to see if something is not equal to a certain condition, you can do so by using this symbol. Another point that needs to be made here is that if an expression contains more than one relational operator with the same precedence, C evaluates the operators from left to right in the expression. Keep in mind, however, that relational operators are evaluated after any mathematical operators in the expression. In other words, if you have a addition and subtraction operation along with a greater than test, for example, the two mathematical operators, addition and subtraction, will be evaluated before the relational operator greater than will be evaluated. The next segment now will look at some specific examples of these if statements and how to construct them. This program, which is called Demo 14 on your CD, will demonstrate the proper syntax and structure of the if statement. The program simply uses a variable, a short integer, called number input. As you can see, it is initialized to the number 0. The program will then prompt the user to enter a number. That number is stored as the variable number input. That number will then be inserted into the if statement, which the condition is inside of the parentheses. If this condition is true, then one statement, the cout statement, will be displayed that will display the message, the number entered is positive. If, on the other hand, the condition entered is false, that is, the number input is not greater than 0, then the statement, the number entered is negative, will be displayed. Let's compile and build this program. And then execute it. When prompted for a number, I'll enter the number 5, and as you can see, it displays the number entered is positive message. Executing the program again, this time I enter a negative number, such as -7, and it will display the number entered as negative. Note that when I run this program and I enter the number 0, that the message that's returned is the number is negative. That is because in the code, the condition being checked for is if the number is greater than 0. The number 0 is not greater than itself. So therefore the else condition, or the else portion of the condition, is being executed when the number entered is 0. Of course, this condition could be phrased lots of ways. You could use the less than symbol, or you could use the greater than or equal to symbol, or the less than or equal to symbol, among other relational operators. Note also that in this case, there is only one statement being executed if the condition is true. I'll enter another line of code, such as cout, and then number, followed by the number input variable. This will cause the number entered to be redisplayed, and then the message, the number entered is positive. But you'll note that there are 2 lines of code being executed. I'll compile this program to see what happens at this point. And you'll note that I receive an error message that says illegal else without matching if. And when I double click on this, it points me to the else statement. But there's actually nothing wrong with the else statement. The problem here is that I'm performing multiple operations now when the condition is true. And you'll recall from the previous lessons that we said that when you want to execute more than one line, you need to include this in braces. So I'll type an opening and a closing brace to surround the 2 statements that I want executed. In this case, the 2 cout statements. I could do likewise for the else portion of this, but it is not required that if you have an opening and closing brace for the if statement, that you also need one for the else. So for demonstration purpose, I'll leave it as it is. Let's recompile the program to see if it's now error-free. Which it is, so we can now execute. And now, once again, I'll enter the number 4. And it tells me that the number is 4, and that the number entered is positive. So it has now displayed both cout statements that I want to be executed when the number entered is positive. If I execute one more time and enter a negative number, such as -5, it only returns the message the number entered is negative. It does not display the number again because that's not included in the else portion of the code. Here. One last comment. Notice that the contents of the cout statements, or the contents of whatever the if statements may be, is indented. This is not a requirement of C, but it does make your programs much easier to read and to debug. Also, the cout statement with the else is indented. And as mentioned earlier, it is a good idea to use a comment to indicate where the if statement concludes, so that you can simply have a visual indicator to you. This means nothing to the compiler, of course, but it lets you know that the if statement has been concluded. This program is Demo 14 on your CD. It is very easy to confuse the equality operator with the assignment operator. In C, the num equals 1 is a statement that assigns the number 1 to the num variable. Num double equal 1, on the other hand, tells C to compare the contents of the num variable to the number 1. This program, Demo 15, will illustrate this point. Note that the condition being tested is to see if the number inputted by the user is equal to a 1. Note the double equal signs. This is the correct version. We will compile and then execute this program. If I enter a number, such as 1, it correctly tells me that the number entered is 1. Re-executing the program, this time I'll enter a number which is not 1, such as 8, and it tells me correctly again that the number entered is not 1. Now, if I change this equality operator to 1 equal sign rather than the double equal sign, it now becomes the assignment symbol. And regardless of what is entered by the user, it is now assigned the value of 1. And irregardless of what is typed in, as far as the input, the message, the number entered as 1, will be displayed. Let's recompile and then execute. Note that this is not considered an error by the user or by the compiler, although logically it is not something we want to allow to happen. So I'll enter the number 1 just to verify that that part does work. I'll re-execute, and I'll enter the number 7. And note that it tells me the number entered is 1, although obviously it is not 1, it was 7. And this is happening because in this code, I am not testing for the equality of the number being equal to 1, I am assigning the value of 1. This is a very common mistake among C programmers. It is one that you must understand the difference of. So we need to make sure we put the double equal sign when we're testing for an equal condition. This is Demo 15 on your CD. In addition to using mathematical and relational operators, you can use logical operators to combine several conditions into one compound condition. The most commonly used logical operators are not, and or. C uses special symbols to represent these operators. We've already seen where the not operator is the exclamation point. The and is 2 ampersand, and the or is 2 pipe symbols. We will look at examples of both of these and or logical operators. In this demo, Demo 16, you'll note that I have double ampersands, which represents the word and. I have a condition, number input greater than 0, and another condition, number input less than 100. And means both conditions must be true in order for this condition to be considered true. So therefore, if a number entered is both greater than 0 and less than or equal to 100, then this message, the number entered is between 1 and 99, should be displayed. If the condition is not true, then the message, the number entered is 0 or less or greater than 99, will be displayed. Remember that the AND operator, the double ampersand, requires that both conditions be true. I will compile this program and then execute it. If I enter the number 50, for example, it correctly responds with the message that the number entered is between 1 and 99. Because both conditions, the number is greater than 0 and it's also less than 99. If I re-execute and enter the number 0, for example, it again correctly tells me that the number entered is 0 or less than or greater than 99. If I execute one more time, and this time I will enter the number 100. It once again tells me the number entered is 0 or less or greater than 99. Again, both conditions has to be true. Since the number was greater than 0, that is 100, but not less than 100, the AND condition is considered not true. So therefore, the else condition was in effect. If I change the ampersand to the pipe symbols, the double pipe symbols, this is the expression that means or in the C language. Or only requires one of the conditions to be true. So now for this condition to test true, either the number input has to be greater than 0 or the number has to be less than 100, but not both at the same time. Let's recompile this program to see the difference. Now if I enter the number 200, which obviously is greater than 100, it tells me the number entered is between 1 and 99. Well, this is not true based on my new program, but the condition is tested true because it has tested true for one of the two conditions, and that is the number 200 is certainly greater than 0. Even though it was not less than 100, it still is considered a true statement since I'm using now the OR operator as opposed to the AND operator. Of course, all these ending and beginning values could be changed to create the exact condition that you're testing for. Given the condition as now written, is there any condition that will cause this to be false? That is there any number which is not greater than 0 or not less than 100? If I execute this program and enter a negative number, it tells me the number entered is between 1 and 99, which obviously is not. If I enter any number at all, such as 0, once again, I get the same message. The way this is constructed, this statement will always execute. I've created a condition in this example which will always be true. Obviously, this is not a properly constructed statement. If I modify this code to now test to see if the number input is less than 0 or the number input is greater than 100, and I reconstructed my cout statements, so if the condition is true, it will now display this message, and if the condition is false, it will display this message. Let's now see if this is a correct logical statement. It compiles normally, so I execute. I'll enter the number -5, and it tells me the number entered is less than 0 or greater than 100. That's a correct statement. I'll enter one more time, or execute one more time. I'll enter the number 200, and once again it correctly tells me it's either less than 0 or greater than 100. I'll execute one last time, and this time entering a number between 1 and 99. I'll choose 50, and it correctly tells me the number entered is between 1 and 99. The key is that I changed this to the OR operator, but I also changed the conditions that I'm testing for. You need to take care that you don't create a condition which is either always true or always false. Once creating your if statements, test your programs thoroughly to make sure that they are testing for the conditions that you are desiring. There are some functions available in the C language which allows you to create programs which are more user-friendly. This program, Demo 17, will demonstrate the use of two such functions, known as toUpper and toLower. This program will prompt the user to enter a grade letter. The user's response is stored in the grade variable. The selection structure then compares the contents of the grade variable to the uppercase letter P. If the letter variable contains the uppercase letter P, the program displays the string "you passed." Otherwise, it will display "you failed." I'll compile and then execute this program to observe its execution at this point in time. If I enter the letter P as a capital letter, it returns the message "you passed" as expected. Executing once again, if I enter the letter F, for example, it displays the message "you failed." Executing the third time, and if this time I enter a lowercase p, it once again displays the message "you failed." If you would like the user to be able to enter either uppercase or lowercase, there are several options. One option is to modify the comparison statement, which is only comparing the grade to a P. You could use the OR operator discussed previously by using the double pipe symbol and then comparing the grade to a lowercase p or the uppercase p. Now, regardless of what the user enters, whether it be an uppercase or a lowercase p, it will evaluate to true and display the "you passed" message. This, however, can become cumbersome when things become more complex. So I'll return this to its original state, and we will use this to demonstrate the toUpper function. Since you cannot control the case of the letters that the user enters, we can use the toUpper function, which is simply placed immediately before the variable that you wish to perform it on. and then place the variable, in this case grade, inside of parentheses. Note that you still have the outer parentheses for the comparison operation itself. It's just that now we have, inside of this, we have the toUpper function. What the toUpper function does is converts the contents of the variable grade temporarily to an uppercase. And then it will compare that to the uppercase P. It is important to note that if you use toUpper on the left-hand side of the equality symbol, you need to have an uppercase inside of quotation marks on the right-hand side of the equality symbol. Let's compile this program to see how it runs at this point. You'll notice I've received a message that says toUpper undeclared. And this is because in order to use the toUpper function, you need a special compiler directive. The compiler directive is the ctype.h compiler directive. And needs to be inserted above the main function. This makes available to C, among other things, the toUpper function. We'll now recompile. And now we have an error-free program. And once again, I'll enter an uppercase P to verify that it does work. It prints U passed. Now I'll execute again, and this time enter a lowercase p to see if we get the U passed message, which we did. Note that if I execute it and enter a non-P, such as A, upper or lowercase, I will get U failed. The only thing that will evaluate to true and therefore display the U passed message is either an uppercase or a lowercase p. You could also do the reverse. You could change the toUpper to lower, but if you do so, you need to make sure that you place the lowercase p on the right-hand side of the equality symbol. Otherwise, if you had a lowercase here and an uppercase on the right-hand side, you would never evaluate to true. One last note regarding the toUpper function and the toLower function. It works only on character variable. It does not work on string variables. As you will learn next, you can use a special function called string compare to perform case-sensitive or case-insensitive string comparisons.